Welcome everybody to Learn with Lowell. Today we're joined with Nikhil Yadala, founder of Healome, fellow at On Deck. He's out in the Bay Area, which I hope is fine. I'm not doxing you. And we're going to talk about what he's working on as well as something he's built, which is LongevityGPT. But Nikhil, welcome to the show.
Thank you, Lowell. It's a pleasure to be here right now.
Like a question and a critique. So I was playing with LongevityGPT and I pinged some of my audience as well, and they were getting stuck with an unable to fetch the reference. This happens often. Try again 4 or 5 times. So it's clearly still in the development phase, because I just kept getting that. I tried it like 10 times, and I think I was just like, getting the wrong thing. Why would it do that? As someone who hasn't worked with ChatGPT, but is very excited for what's going on, and I really like what you've done with LongevityGPT, just as the idea of it and what you've shown before. What would cause it to be stuck in like a loop like that?
There are multiple reasons for that. One of the reasons is LongevityGPT, the final layer of answering is paraphrased by GPT to do a human-like conversation. And OpenAI has rate limits. Depending on how many people use it, certain times, the questions do not even go until the backend of OpenAI. And this is purely a restriction from their side. The only way to circumvent that is for us to use your own keys, which we're not doing right now. And the other scenario would be like, one of the other reasons is sometimes when we do not have an answer for a question, we try to fetch the research articles from the internet to curate the answer. And this fetching could be extremely slow, depending on how much loaded the server is. And then we do not want to answer anything just because we can answer. We want to be able to make sure that we can attribute each line to the source. So we just don't answer if we cannot fetch the documents.
Yeah, makes sense. And yeah, I was thinking, because I've been looking at ChatGPT, LLMs, as well as OpenAI, which, depending on how Elon Musk looks at it, is actually closed AI. But I think having an option where it's like, hey, if you want the free version, which is what you're providing, no cost to anyone. So it's like anyone who gets frustrated at the development or like being slow, it's like you're getting it for free. Maybe relax a little. They could like plug in their own API token. And then, like, I don't know, like a little form, like, hey, if you want this faster in real time, like, put your own key in there. Is that something you could do, or have you thought about? Like, what do you think about something like that?
Yeah, definitely we could do something like that. But the thing is, longevity researchers or general health researchers do have access to their OpenAI keys. But this application was designed broadly, keeping in mind, the common population who generally have certain questions about what's the current state of aging research, and general questions about health. Most such people, they never apply to get an API key for GPT-4. They do not know about it. So I think doing some form of a separate tool for researchers versus common general people would probably be a better thing to do going forward.
Yeah, that makes a lot of sense. You're making it for people, making it easier for them. And as someone, when I was first figuring out like API keys, it was very confusing for me. And so, at a certain point, it's just like you click a button and then you take it and move it on. So making it user friendly, I think, is really awesome. How do you go from the? So I've been reading some of the documentation on OpenAI, and everybody, don't worry, like we'll define these things. But the OpenAI was founded by Elon Musk, and then Sam Altman, and then there's a Itai, the big CTO science guy, was really the brain behind it all. I think his name's Itai, and the basic idea is like it's a giant LLM thing. Why am I doing this? How would you define OpenAI? And then we'll dive more into like how it all fits together. Because like ultimately, like we're building off of something that is from them.
Yeah, definitely. So I have been following OpenAI since their inception. Initially, they really had open sourced the parameters of all the models that they used to build. And I believe until GPT-2 time, everything was really open source in the true sense of open source. After that, most of the large models, not just the language models, but also image-based models as well as speech models. These were not really open source. There was only an API access to use the model. There is always a trade-off between how much. It's always a trade-off between ethics and the usage of the model versus your true goal that you wanted to start the project with, which was to make everything open. There is a possibility that people could misuse it, and there is a need for regulation, but nobody really knows how to regulate it. But I just want to say one thing. 4 years back, there was so much scrutiny on how Google, Facebook, Microsoft, all these large companies use their data and privacy. But right now, with so many people using OpenAI models, they are sending a lot of data to OpenAI, and nobody really knows very clearly as to how that data is being used. And I don't know where all of that. I do not know. Let me put it this way: people were too careful about privacy 4 years back, but it looks like people are less careful about privacy right now. So times have changed.
Mm-hmm. Yeah, I think it's more like it feels like change blindness, that you're just getting used to, well, we don't have privacy anymore, or they don't realize that, like you're saying, that there's something going on there. Why do you think that they went from open source or relatively open source to closed sourced? And it's particularly interesting because there's a lot of really powerful open source models being developed right now, and it seems like, over time that they might become more competitive and stuff. I don't know. We'll get into the landscape in a minute, but what would be your guess? Because you don't know, but since you've been following from the inception, why do you think they made that change versus being like limited open to closed versus just maybe make it even more open and really being true OpenAI versus from pseudo open to now really closed AI, I guess?
Yeah, it's tough to answer, but in good faith, based on what they have been telling, I genuinely believe that it's a concern from their side on how these models would be utilized by people. They could be misused. We have seen a lot of deep fakes based applications in the past, which were also used which were also used to mislead elections and also deep fake spawn and abusing people. So there is a real possibility that there will be a set of people that would misuse this technology. And I think OpenAI just wants to regulate the extent to which these models could be misused until they figure out a better way of regulating it.
So if you were in the seat, you see it as reasonable for them to move from open to a closed and be their own artificial regulation as they wait for regulation to catch up?
I think not. I'm not exactly comfortable with the model parameters not being open sourced. It's just that for now, I think it's okay since they do provide access to the model via APIs, and we do have certain transparency on how the model is going to work. But I think collectively, all of us have to reach a consensus and talk with OpenAI to decide, how we should go ahead going forward. And also, there are a lot of other large language models which are completely open sourced. So if the other models are really very good, OpenAI would be forced to open source the parameters despite the risk of being misused, is what I think. But the pace at which things are moving is so fast that I'm not able to catch up with them. So I think the best thing to do is to wait and see.
Yeah. What are model parameters, and why do you feel like why would you like them to be open source?
So model parameters is basically, so all of these large language models are complex neural networks with multiple layers of neurons. And every neuron has a weight associated with it. And these weights get decided when the neural network is trained from a huge corpus of data. In case of OpenAI, this data was collected from the internet, whichever was publicly accessible. There is a concept of differential privacy. So what it means is if you have access to a model and its parameters, one can theoretically, to an extent, reverse engineer the model and figure out the data on which the model is trained to certain extents, not completely noiseless. However, there is a possibility of data leakage from a model. And if people get access to all the data, then some of the data may not be publicly accessible anymore, but it would be violating the privacy rights of the people. So this is just one of the theoretical risks that's possible, but also people could fine-tune the model to certain non-ethical applications because it's a very powerful model and it works with a lot of languages. It's easy to fine-tune it in a short amount of time for a completely different task that's not intended to. And we are giving enormous power to everybody. So I think these are some issues that we need to figure out how to regulate, without which I think nobody really knows what's the extreme amount of damage that could happen. And also nobody really knows what's the extreme amount of good that could happen by truly being open. It's a very tough question.
Yeah. It seems like we're in a new revolution going on with all these things. I'm curious what jobs it creates, what jobs it destroys, and stuff like that. For me personally, the biggest thing that helps me with is that sometimes when I'm doing research, it can this is like a really complex algorithm. Can you break this down for me? And so then I can have a much more nuanced question, which makes my job as someone who's going to interview someone, or if I'm doing research for a project, that's pretty useful. How do you use these tools personally for yourself?
I have been using these tools. One of the biggest use cases that I have been using it for is writing certain code. In building some day-to-day applications in my work, I would have to code in several languages, and I'm not good in most of the languages, so I have to Google anyways. But then I have seen that GPT-4 is good to give me some initial template to get started. So it just improved my productivity by, I would say, maybe 5 times in the last month. That's one of the biggest things. And the second thing was, sometimes when a question is complex, if you have a very complex theoretical question, whenever I go to Google search or Bing search, more often than not, I don't get good results. If you have a generic query of 3 to 4 words, you often get decent results. But if my query is very complex, and let's say my question has some 20 words, it's a very scientific query, unless there is a specific blog that discusses about that query, I would not get any result in Google. However, GPT-4 seems to have a very good retrieval capacity, and it's able to collect the answer from multiple sources. Even though there is no single blog that talks about my question, it can understand that my question probably relates to 100 blogs partly, and it tries to create an answer from 100 different sources, which can partly answer the question. So for such complex questions, I have been using GPT-4. And it's interesting. I never thought that large language models would be so good in retrieval.
Yeah, I'm definitely going to echo your point on using it for code. My ability to learn is just going through the roof in terms of the coding of it. And sometimes one thing I have done is I'll give it like a code block that I've written, and I'll say like, hey, this thing that I have to do next, can you write your example how I write things? So then it's even easier for me to get it, because I have like some weird things in how I code. It's probably inefficient, but versus just it giving it. But yeah, templatizing it is very powerful. And even your point of going to it versus Google, I think even Google is starting. I think their recent thing, it's all AI based. Like it's you wouldn't think they're a search company anymore, and that it's like, oh, look at all our AI tools. Like I think more people are going to ChatGPT now to ask questions than anything else. And I mean, even Bing, which has been like the butt of every joke for the last 15 years. I don't like, oh, you use Bing, are you an idiot? I don't know. People are going to Bing because they have such a powerful integration where you can ask questions and have a conversation. Yeah, it's like it's like a new age of something going on right now in terms of just researching and learning.
I used to, in fact, work in Bing ranking team previously, building ranking models. And as a matter of fact, both Bing and Google had question and answering for a very long time. Rather than just showing results from blogs, they also write an answer at the top. It's just that question and answering problem has got much more better over time, and GPT-4 has like accelerated the accuracies of the benchmarks like way beyond the existing Q&A pipelines. So I think now Bing is anyways integrated with GPT-4, and Google also says that in the recent keynote that they have LLM to generate the answer. So yeah, I'm curious to see how all these companies would compete with each other, because personally, I think Microsoft and Google have had decades of experience building infrastructure to be able to search through billions of documents within milliseconds. And they have the compute and infrastructure to be able to deliver the answer for millions of people every week without any issues with latency or any downtime. But OpenAI has been a machine learning company that has been training models. They don't really have infrastructure built specifically for search or question and answering. So I don't know how long would it take for Google or Microsoft Bing to catch up and take all the users that are going to GPT-4 to them.
Well, I think the Microsoft owns a big chunk of OpenAI now, so it seems like that'd be like an easy integrate. You know more than me on this, but I think they own a big component of it now. They're like a big stakeholder or something.
Yeah. I only know as much as it's told in the public media, because I'm no longer associated with Microsoft. But I still do not know how much of the model access does Microsoft have. I'm curious. Do they really have the entire model parameters, or even if they do have, is it only in GPT-4? I could not find any of this information online.
Yeah, I think there was a recent interview with Elon Musk and CNN, and he posited that they have access to the weights and measures, like the parameters you talked about earlier. I could be misremembering that. Also, he's out of the kitchen, so he might not have up to date information anymore. And he seemed pretty upset at the time. So all caveats around there. Is it, as someone who worked on Bing, is it satisfying to see Bing be like kind of resurrected a little bit? Not have a bigger place on the internet.
No, I definitely feel very happy that people started using Bing because it may seem like it's a biased statement, but as a matter of fact, even 4 years back, Bing was decently good in providing correct search results for a very significant percentage of the overall queries. It just so happened that Google was better than Bing in majority of the queries. So people never used to go to Bing. So that's how we never knew that Bing was good. But in fact, there were certain segments of queries where Bing search was sometimes better than the Google search results. But their ranking models have been in development for decades, and now they also and I guess now GPT-4 is also associated with their ranking model. So now I definitely feel happy that all the work that people are doing in Bing has now become fruitful, and people are going to be using it.
So tying this back into what you worked on with LongevityGPT, how do you go from GPT 3.5 or 4 to fine tuning it to have LongevityGPT? We could you take the idea and show us the execution.
Yeah. So GPT 3.5 or GPT-4, since it's a language model that has been trying to predict the next word, it doesn't really have a world model of health or longevity. It just basically says a sentence that statistically feels right. but it cannot causally understand if doing X really leads to Y. Because of this, there is a possibility that it says sentences that could be not factually right, but it seems right. This is the reason why, you only go to, if you have any sickness or any illness, you go to your doctor. You don't ask your friend for advice, right? Because your friend also may say an English statement which may seem correct, but you don't believe him or her. You go to your doctor and only believe them. Similarly, so GPT-4 could say anything and hallucinate. So even if you fine-tune GPT-4 just with longevity and health papers, it is still a text model. It is not trying to understand the underlying biological pathways. So it can still hallucinate. If you fine tune it too much and using very good regressors on loss functions, the probability of hallucinations and errors could be decreased, but it can still do mistakes. And since it's a language model, right, it's not a longevity model. So the only way, so the way LongevityGPT is constructed right now is, when a question comes, there is a layer of search. This doesn't include GPT-4. It tries to search from the internet and gets all the relevant research articles that are currently open access. And once we get all the papers, there is a second layer of search that tries to fetch the relevant passages from the papers, which could have potential answer to it. And then there is a third layer of trying to summarize all these passages to create one line of answer, to create one paragraph of answer. And then we send all of these answers and the content to GPT-4 to paraphrase it, so that you can carry the conversation in a human manner and hold the context for a longer sessions. For example, if you ask question 1, it generates an answer. If you ask question 2, which is a subset of the answer, that context is part of the GPT. So the paraphrasing would also understand that this is a second question related to the same topic. And then there is another layer of validating whether the final answer is really associated with the source or not. This is how the current LongevityGPT is built. We are not exactly fine-tuning the GPT-4.
Yeah. So you can refine off of ChatGPT for what you're doing, but really it's more like so if I'm understanding it, you search the internet, find the information, use ChatGPT, synthesize it into a format that people can appreciate, and then allow them to engage with that content, potentially pull in more information based on the queries that they do from that point on.
Yeah.
Yeah. So I think I was reading that you can do some fine tuning of the ChatGPT LLM itself or some of their other models. Was there any thought into doing something like that? Because I have read, the headlines of this, but I haven't looked into it yet, that there are some LLMs that do health records or health information where you can ask it questions and it can give you like pretty specific stuff. I don't know how they work. I read the headline and I have not, I have the article pulled up. I'm going to read it later. But have you thought about, would there be any benefit in refining the model to what you're working, what you wanted to do with this? Or was it just like, I guess taking a step. Yeah, go ahead.
No, I think GPT-4 has, not GPT-4, OpenAI has API which allows us to send our own specific set of documents and fine tune the model. And I think they would be retraining the model for a few epochs with the new data set that we provide. So the model has an understanding of this specific topic. And it's definitely going to be better than using the existing model without fine-tuning. However, as we just discussed, even this fine-tuned model can hallucinate. Now it may know all the vocabulary of health and longevity. So, in a way, we are giving it a power to hallucinate even better. It's like now it can lie, and you would not know that it lied because it used all the right words.
It's like the in philosophy, it's like the Chinese box. If you're inside the Chinese box, it's like you don't actually know what the symbols mean. You're just outputting the correct symbols based on the little diagram you have. Like it's an actual understanding, and you could be doing it wrong and not even know it. Yeah. What do you think about ChatGPT, OpenAI, I don't know, OpenAI versus ChatGPT, but OpenAI versus Google, what they have going on versus like some open source models. What do you think of the different ones out there? What do you think's like on the cutting edge?
I have been playing with some of these models, Bard, Llama, and GPT-4, and also GPT 3.5. There are several differences between the there are several differences among the accuracies of different kinds of prompts with respect to each of these models. I think these differences are majorly coming from the training data which was used under training procedures. I cannot really say that GPT-4 is always going to be better than any of these models, because I have been seeing on Twitter and on some other articles where people found certain use cases where Bard was much better than GPT-4. So going forward, I think we can, if we do have access to all these models, when we do create applications, we could create an ensemble of all these models, right? Like we can take the outputs from all of these models and do something that fits for our application. But what I do know is these are so large language models with trillions of parameters that training once on hundreds of GPUs takes like 3 months or so. So no matter how big the company is, we do have certain limitations on how quick can you train such a model, taking all this probably several gigabytes or petabytes of data and being able to access that seamlessly to train a model and being able to scale the training over hundreds of GPUs. There is a limit to, I mean, it's not like even if you have money, you cannot put a million GPUs and distributedly train it. Probably you can, but not today. Most of the models don't use, they barely use like around 1,000 GPUs or so. So it does take like 2-3 months to train one version of the model. And probably you would want to see the feedback and iterate on it. So it takes even more time. So people are not going to be able to suddenly come up with a new model just overnight. So all these developments will take some time. So within that time frame of 2 to 3 months, I think we can only, all that we can do is to just use all the models that we have access to.
If I gave you, Elon Musk's checkbook and, a team of people, is there a project you'd want to build a model on? Like you could just like develop and be just creative and fun as you'd want to be on it. What would you want to do?
I would like to solve aging, figure out how aging manipulates, how aging is manifested in human body, and figure out the biomarkers of aging and come up with drug candidates that could potentially target these pathways and solve aging.
How would you go about doing that? Would it be like there's two different types of how would you do it?
So there are two aspects to solving aging. The first one is drug discovery. We already know several pathways in humans as well as in animals which are affected by aging. And we have to figure out the structures of drug candidates that have specific physical and chemical properties. So there are some machine learning models that could aid in this drug discovery process, like doing in silico drug discovery. So that's one aspect of it. But there is a second aspect of this, which is biomarker discovery. Even if I do have a drug that, let's say, periodically helps you age slower, how can I prove it in humans? We need to do a randomized controlled clinical trial. What exactly are we measuring? If I say that, if I give you a pill, and if I say this pill slows down aging, how can you prove it in humans? When it comes to animals, you could prove it by doing a trial and establishing that the rats that took the pill have lived longer and healthier. Because the trial typically is for a period of 2 to 4 years or 8 years, and you could, by the end of 8 years, say whether the rats that took the pill lived longer or not. If you give it to humans, humans already live so long. Like the average life expectancy in several countries is 70 years. So this trial is going to be there for several decades. And even after the end of the trial of several decades, you cannot causally say that the people who live longer only precisely because of this pill, or not because of any other aspect of their life, because humans are much more complex than animals in labs. So there is a need for identifying biomarkers in the body that are indicative of progression of aging. If you do have certain consensus on what these biomarkers are, then when we have a drug, aging drug, we can measure the directional change of this biomarker over a period of time, let's say 2 to 4 years, and with a reasonable confidence be able to establish that this drug really works for this specific pathway of aging. So we need to do biomarker discovery, and I would go by starting to do a very much better analysis of the existing aging clocks, and also collecting the data sets from all over the world for various blood and gut microbiomics, like all the data that's possible, and be able to train clocks and do a retrospective analysis of how much efficacy does this clock have in terms of predicting age growth. Yeah, like I would start doing all of this work and figure out what the biomarkers of aging are.
Mm-hmm. So when you gather the data and you're going to run it through some machine learning, do you have to build the machine learning algorithm yourself, or do you just take some off the shelf algorithm that exists and then tweak it for your needs?
If it were up to me, I would build one myself, because there is no off-the-shelf machine learning aging clock algorithm that is like good. I mean, unlike machine learning in text processing, we don't have any large language model. Like, we do not have any large model in longevity that everybody really likes. And we don't have proofs that the existing models are really good. Every model right now has certain limitations because all of these existing life sciences models are trained on limited set of data sets that research lab has access to. So I would, if I have the money, I would start training a new model with all the data without any biases of the existing models.
How much? I think I was reading somewhere that it was like $1 million or something, just in terms of like the power or something for making ChatGPT 3. I think it was like it's fairly expensive. I think that was just like one component of it. So how expensive would it be for just in terms of the compute, machine learning, that element of it? I guess storage, but storage is pretty like inexpensive, like for petabytes and stuff of information. Like, it's not really that expensive.
Yeah, I mean, generally storage is not that expensive. What's expensive is being able to do an efficient search over the storage to retrieve the relevant pieces of information super quick. And if you have any update to the storage, being able to put that update at the right spot at the right time. Doing this compute operations to search efficiently and to fetch the document and to write the document, we would need distributed databases. And I think that's very costly to be able to build that infrastructure. How much would it cost? It's a very good question. If you are training some model that is as big as GPT-4, then of course, again, it would cost the same amount as GPT-4. But to begin with, we don't really need to train such a big model because we do have access to a lot of text on the internet. So it was possible to train large models. Right now, we don't have access to that much volume of medical information. So even if you have lots of money and a very big model, the amount of data you have is limited and the model would not get trained. The parameters won't be learned properly. So it's completely limited with respect to how much of a data access you have. And the data access is something that probably cannot be solved just with money. It needs to be solved with all the government regulations, people wanting to help data be open access and data access be democratized. And this is something that the policymakers have to allow. Just throwing money at it might not give you democratized data access.
Yeah. And we're talking like medical records and stuff, right? That you need.
Yeah.
Yeah. I think you were saying earlier that if you like people would be able to like reverse engineer through the data to know like so then if it was a private record, like would someone be able to look if you were to anonymize the data, would someone still be able to reverse engineer what the data was and then like link it to people?
Someone would not be able to do it if you had used right techniques to train the model and right techniques to reprocess the data. So the field of differential privacy engineering tells you how to do it properly in such a way that you get periodical guarantees on the extent to which the data can be reverse engineered. So if all those principles and techniques are rigorously followed, you would not be able to reverse engineer the data and lose privacy. And also, second thing is we do not really need access to we do not really need access to identifiable, personally identifiable information. In order to learn a model that's good for biomarker discovery and for drug discovery, we can use data sets that are already anonymized. We do not need people's names and their address or any such things, right? So, so we can. So the machine learning model would have never seen any personally identifiable information. So there is no way it can be traced back. Yeah.
So it comes to you clean, and you can even make it more obfuscated. So it's even like unnecessarily obfuscated, I guess, in this case, because like you never would have had access to it. So we have the data. How many people, like how deep does this data or wide does this data need to be for it to be usable? Would it be 1,000 people? Would it be 10,000 people? I'm just like going through with this thought experiment now. I'm curious, like maybe like we can like slowly form people, but like how many would be the minimal viable depth if we got like if we could get like 1,000 people, whatever, how many people would you want? And then, we could start talking about like how much data to grab from there, but how many people's worth of data would you need to start building a model that would actually be usable? Minimal viable data model, MVPD. Something.
Yeah, I think it really depends on the complexity of the problem that we are trying to solve. But no matter what problem you're trying to, no matter what sub-problem you are trying to solve in biomarker discovery or drug discovery, it is important to be able to collect this data from all over the world. If you're in university in California, chances are you have very good collaboration with the hospitals in the US and mostly hospitals in California. So you already get access to the local hospitals' data because of your research collaborations and grants. But there are a specific set of people that live in California. It's not a good representation of the entire world. And this applies for every research lab across the world. Every lab has their own partnerships that are regulated by their grants and their governments. So if you really wanted a machine learning model that is truly biasless, one of the biggest driving factors of bias is the training data that you use. So you need to make sure that the training data that you take is representative of the world, which means you need data sets curated from all religions, all ethnicities, all countries, all socioeconomic factors of people. So, and within each of these clusters of unique sets of people, how much data do we want really depends on the question that we are trying to solve. For example, I was working on building an aging clock based on blood markers. And I was using certain data sets from India, US, and the UK. And so far, we have used around 500,000 records from research grants. And the accuracy keeps increasing until we don't know. So what it means is we still haven't reached a point where we say that this is enough. If you do get access to even more anonymized data, the accuracy of the aging clock may increase even more. So this is such an empirical question that that can only be answered by actually trying it out.
Mm-hmm. Yeah, it's a huge problem to have too. And I was trying to think like how could you bite size it and slowly like build out from there. But to really have a powerful model that can be usable for everybody and be robust, like you would need to do it your way. Okay, so talking about, so we have people all over the world. We have a Noah's Ark worth of people, more than 2 of every group that exists. But would you have to build the servers yourself, or could you just do like, AWS or something to do the compute?
There are actually very good open source services that are already built for this precise purpose of being able to share healthcare data by preserving privacy, and also being able to authenticate people using zero knowledge proofs, and be able to securely transfer the data sets from one place to another place and keep a track of all the data transfers in a way that is completely immutable, and that is completely verifiable using blockchain. And it's not even a sci-fi thing. There are open source platforms like this that have already been built precisely for this. So it's just a matter of all of us really wanting to get this done and start utilizing these platforms.
Makes sense. And then when you're doing the developing, your background's in software engineering and that type of thing, but you're also founding companies now as well. And we mentioned one at the beginning. Just want to like make sure we reference it. Healome. What is Healome about? Yeah. I feel like it's kind of related to what we're talking about.
Yeah, definitely. So Healome is basically, it's a mobile-based application that helps people to figure out how to age slower. And the way it works is you do take certain blood work. You could take it from anywhere, from your nearest laboratory. And we have made some aging clocks that try to compute your full body age and organ-specific age. And then you connect your health variables and see how you could manipulate your existing habits, for example, coffee intake or alcohol intake, and figure out what's the most optimal routine for you to slow down your aging as much as possible. This is one of the aspects of Healome. The second aspect of Healome is something related to what I was just talking about. You could be anywhere in the world and choose to contribute your anonymized data for a decentralized trial, and you would be rewarded for doing so. This is just our efforts to increase the transparency and also decrease the gap between research and the people, right? Like, if you ever search, is coffee good? You will find a lot of research articles such as coffee is good. Mm-hmm. Now change your search query and ask, is coffee bad? You will find a lot of research articles such as coffee is terribly bad. Same thing with beer, same thing with wine, everything. That's because every research that's ever done is done on a specific set of limited people. And for that subgroup of people or for that person of people, coffee might be good or might be bad. So whether it's really good for you or not is something that you would never know. No matter how much of an expert you are in understanding scientific literature, you would always get mixed papers. So to be able to, at a personalized level, understand whether a specific protocol or a drug or supplement is good or not, you need to have more personalized data while preserving privacy and having anonymity and allowing researchers to be able to assess if there is any causation or correlation with coffee. So we have built this platform that enables for such a thing to happen, basically decreasing the gap between researchers and the end users' usability.
And then you're building that, I assume, on deck, which I think is at Berkeley. It's like Y Combinator, but at a university, if I remember correctly. Yeah.
On deck, it was right now it's also like virtual. So I was at On Deck Health and Longevity Biotech. It's a group of people who some of them are founders, and some of them have been researchers, and some of them had several exits. Basically, a set of people who are all interested in building some products in this space, helping out each other with either brainstorming or collaboration and partnerships, or just any suggestions and ideas. So it's been very helpful for us to get deeper into this space and make really good friends along the way too.
Yeah, I was out in the Bay Area once, and I think the groups that come together. I mean, in this case, it's virtual, but when you can get together, like the energy of it's like is quite powerful.
Yeah.
It's just like everyone's really supportive. It was like, okay, I can see why startups thrived here for such a long time. What have been some of the milestones of LongevityGPT? Which it sounds like LongevityGPT was really like a philanthropic, like sort of open source thing that you were working on for your own benefit, but also to help other people. Where Healome is more of like a business that you're working to do to help other people, but also to like make a business to differentiate the different things you're doing.
Yeah. So one of the things I realized after launching LongevityGPT is that, which is intuitive after realizing it, but it was not intuitive to me before. That is, people who care about longevity, of course, have a lot of questions about general health as well, not just about aging. Going back to the example that I just said, right? Like how much coffee should I take? How much sleep is too much sleep? Is it okay to like some of the questions that people typically have is like, I'm too stressful. Stress is of course bad. So can I have a glass of wine or beer to decrease the stress? But of course, wine or beer is also bad. Now, which bad is more bad? Like, how do you quantitatively evaluate the risk of your stress versus something that you are doing to relieve stress? These are all questions too about health. And people who are interested in longevity and aging are also interested to answer these questions, even though these questions are not directly related to longevity. So what we also ended up doing is index a lot of papers pertaining to general health research, and also podcasts of Dr. Andrew Huberman, Dr. Peter Attia, and Dr. Eric Bird, because these people talk specifically about various day-to-day life scenarios, which are very helpful for people to figure out what they should do. And you could link your health data from Healome app into this health bot and get very personalized answer for your scenario. And similar to the ethos of LongevityGPT, you clearly know where the answer came from. Is it something that Dr. Andrew Huberman said, or is it something that a specific research paper from a specific lab has talked about? So you know where it's coming from and how much you should trust it. So Healome is also linked with LongevityGPT for personalized health, but LongevityGPT is also a separate thing that's just for researchers to use as a literature review tool.
With any of these things, is there an ability to, like we talked about earlier about, what do you do with the data? Like even the questions are useful for OpenAI and what becomes it for a privacy standpoint. Could you use any of this to start building your own database to do machine learning or whatever on, like build something off of it? Is that like something that can be done or a part of the vision at all?
I think it can be done. We do not store any of the data at all in whatever platforms that we built so far. And even in the Healome, whatever data that gets stored is already stripped of personalized information. And we do not use any of this data to train the models. That's just our privacy policy. We use the data that has already been collected by biobanks and other research institutes to train our models. Secondly, there is a possibility in future to be able to use our users' data to train the models. And of course, it's going to be good because you have the ability to create biasless models, as we just discussed. But before we do that, I think all of us, not just you or me, all the users and everybody in the world has to come onto conscience on how much privacy is good and all these things. Like I am a very strong privacy advocate. Like I want, I do things very carefully considering the cybersecurity and privacy aspects. So we do not use anything as of now, and we do not even store the data. But I really want us to have discussions about that and decide a strategy so that we are in a position to build biasless models going forward.
What I think we've talked about it previously, but what all would you need to build a biasless model? Like if you had like a checklist, what all would need to go right for you to be able to do that? It sounds complex.
Yeah, so one of the things is, of course, the data coming from multiple countries and multiple groups of people. So the data has to be biasless. And second thing is, at least part of the data has to be longitudinal in nature, meaning, let us say, if you're collecting your regular preventative blood work, let's say, in order to make sure that whatever the machine learning model has said is really accurate, it is very important to have at least a part of data to be longitudinal in nature, let's say with a periodicity of maybe 1 year or 10 years, depending on the problem, so that we have access to the follow-up data points to see whether the machine learning model has done a good prediction, because we'll have established a ground truth with a follow-up data point. Again, most healthcare data sets, even if you do have access to data, there is no follow-up information. And if you build a machine learning model with all the data, if the model predicts something, in order to know the accuracy of the prediction, you need to follow up with the people. But we just discussed about data being completely anonymized and there is no personally identifiable information. So there is no way you can contact the people and figure out if your model is doing good or not. So it's very important for the model, for the data to also be longitudinal in nature. And this basically gives us a small restriction. Data collection and electronic health records have only recently started, like maybe 20 years back. So all the data before that, first of all, majority of the data is not collected ever. So there is a limit to how much longitudinal information that you could get. But definitely we need longitudinal information to the extent possible. And also get continuous markers because of the variables like the watches and rings. If you do have access to continuously screened markers, we would be able to approximate certain hard to get data points, maybe from certain hard to get data points from blood or genetics. We'd be able to build such models. And then we, of course, need resources like money. There is no dearth of talent of machine learning researchers who are very good at machine learning and also very passionate in building models for health and longevity. But I think there is a very strong limitation or an amount of funding that goes to the intersection of machine learning and longevity or health.
How much money, in a ballpark way, would it take to get like an MVP of everything that we're talking about right here in people's hands?
So if you're talking about just like an MVP could be made maybe in just like $3 to $4 million with all the existing data sets that we can already access from. But in order to truly improve the accuracies and be able to prove everybody, including FDA, that using such machine learning models is a decent way to conduct trials, we would need several more million, probably for every trial that you would do. If you do decentralized trials of supplements, each trial would involve recruiting people who take that specific supplement and also funding the researchers to do an analysis of how well the supplement has worked and also the cost for tracking the data continuously and anonymizing them. So for each trial on supplement, I would, on an average, assume it would cost like around 1 to 10 million, depending on how much, depending on how many people you do the trial on, depending on the scope of the trial. But once you do like maybe 5-6 trials of supplements, and once all of this data is democratized, then I think it starts being a proof of concept for all the government regulatory agencies in the world to look at the efficacy of such a trial and start accepting machine learning models into the clinical trial endpoints. So I think at that point, everybody in the world would come onto a consensus on we should be using machine learning models, and from there onwards, it's just a matter of how much more you want to do, and money keeps coming in.
Mm-hmm. Have you are investors on board? Like, how is that, like, you can be doing a raise, I assume, or how are you going to do it? Is it going to be like an open source thing or like a nonprofit? How do you see your organization being able to do it?
So Healome as a company is a non-profit. It's a for-profit company. So we do have some investors previously, and we are again going to be fundraising soon for our next set of activities. We already do have, like, for example, a product line that you could start downloading and use. It's a mobile app on both App Store and Play Store, and figure out like what's the best anti-aging protocol that you should be involved in. But the trials that we want to do over supplements eventually is going to be open sourced and completely democratized. Like, we do not want to own the data of the trials. We do not want to be the truth bearer of the trials. In fact, it's designed in such a way that anybody can come and contribute to it to the point that you are incentivized to disprove what's happening in the trial.
How do you make money? Like, how?
So the trials we would not make any money from the trials. It's just a platform for people to be part of the trials, and the people who are interested in conducting the trials already get money from their own grants or their investors, right? So that's the money that goes to the people as a reward, and we are just a platform that facilitates all of this with the fees. But the for-profit Healome company makes money from the users. It's a direct-to-consumer product. If you are somebody who is interested in figuring out your biological age and figuring out your protocols for what works best for you and getting all the personalized answers, then there are certain fees associated with it, and you would pay to the extent you find it useful.
So the platform would be kind of like Amazon in a sense, where you just take a percentage of whatever transaction happens on it?
Something like that eventually, yeah. But these are completely designed keeping in mind of a decentralized trial. So it's basically tokens. It's not like real currency. It's a token as a gateway access to a trial, and the price of the token would go up or down depending on the quality of the trials and the depending on the quality of the trials and how people perceive this way of doing trials is. If everybody in the world suddenly starts believing that doing clinical trials is completely useless for whatsoever reason, the token price goes to zero and we make no money. Nobody makes any money here. If everybody believes that doing a decentralized, open access, trustworthy trials is good for the humanity, and if people want to do more and more such trials, then the token price goes up, which means the incentive pool for the people also go up. Yeah.
And then a fan listener question. Enough Concentrate 21. I'm glad it's not like a real name, because then I feel like, oh, should I say James or whatever wrote in, for doxing people and stuff, because I care about privacy as well. But all right, so Enough Concentrate 21. Computer science guy to another computer science guy. What problems would you say these ML algorithms allow you to solve that weren't tractable with prior tools? With prior tools, why, and what advice would you give to someone who wants to start researching these medical topics and see what new techniques he can cover in this area of methodology on their own computer? I think there's like several questions in there, but yeah. Enough Concentrate. Here, we asked your question.
Yeah. One of the things that I would suggest is, if you start looking at the current research papers on arXiv for any general machine learning task, like personalized recommendations or search recommendations, you would see that the kind of models that they use are too complex and big, and the state of the art keeps changing probably every month. But if you go to any life sciences paper or any computational biology paper trying to predict gene expression profiles or protein-protein matching affinities, or even drug discovery papers, the state of the art doesn't move at the pace at which the state of the art moves for general ML questions. And you could also see that the models are not too complex, because one of the reasons is we don't have too much data to make a very complex model over there. But the more papers that you read in archive, in CS archive versus bioarchive, you would get several ideas on how you could improve the state of the art in the life sciences and biology space. And you can start seeing where people have collected the data sets from. Some of them are completely open access, and you could also collect it from there. I also like this group called Dream Challenges. Dream Challenges group, they convert a lot of biology and medicine problems into computer science and machine learning problems for anybody who is completely for somebody who is only associated with CS and machine learning. It provides a way for them to contribute to biology problems, because they do a very great job in condensing a biology problem into CS problem and give you lots of primers on the on that specific topic. Yeah, so I would say these are the good sources to go into. One of my research areas of interest is multimodal machine learning, in which I have majorly worked in the last few years. When it comes to general machine learning, we have these things called embeddings. For example, OpenAI embeddings, and also every large language model has embeddings. These embeddings are a good representation of the text, and it encodes a lot of information on what the text is supposed to mean. And because of the open source nature of general CS and machine learning, several people build on the same models and keep improving the efficacy of these embeddings. But in life sciences research, every lab builds their own model, they create their own embeddings, and there is very less collaboration. So there is no gold standard for any vector embeddings for any kind of either molecules. There are embeddings that are open for sure, but they're not as great as, for example, OpenAI embeddings for text, because people work in silos. So I think probably, I hope that GPT-4 makes it easy for everybody in all the fields to realize that embeddings are very important. And if the access to data is siloed and limited, it's important to at least collaborate on making large models in a collaborative manner, so that you could at least open source the embeddings, not the data, because data needs to be private.
Okay. And then when you do your market research, and enough concentrate, I hope you that answered your question. When you do your market research and customer validation, what is the process you go through to make sure what you're building is something that people want?
So I just spoke to a lot of people, probably like 600 plus people. And I generally try to understand what is their, when it comes to health, why do they want to become healthier? This has always been my, like everything I try to do the research on surrounds this, because everybody says that they want to become healthier, like, but why is my question. What I realized is the more deeper you dig, there are some common reasons why people want to become healthier. One of them is because everybody has some passion towards something, and they want to be able to do that much more productively, whatever they're passionate about. And second, in today's world, like, I don't know what the answers would be maybe 10 years back or 20 years back, but this is all the research I did like 2 years back. So in today's world, everybody has so much stress. People have to do certain things that they don't like to do just to be surviving. So people want to decrease their stress levels, and that's one of the, they want to become more resilient to stress. So that, again, I think they can work on the things that they're passionate about. So decreasing stress. So I feel like these are the two main things. And some other people want to be healthier because they want to stay and live longer and have a good life with their loved ones, either spouse or parents or children. Uh, so once I understood that these are the main things that people fight for, then it's easy to build solutions around these aspects. I mean, if you want to make some healthcare tool, healthcare is so broad. How exactly are you going to solve the problem? It becomes much more easier to solve a problem if you try to understand why do one want to even become healthier and go to the root cause of it and try to solve those problems. For example, helping people regulate their stress levels, helping people give more time for something they're passionate about. This is the reason why I directly got interested in one of the reasons why I'm interested in longevity. If you age slower, you have more physical and cognitive capacity to work on something that you like the most. Yeah, this is how I do my research.
Makes sense. Is there an element of that you're well, this can lead to just a separate question of itself, but Learn with Lowell, learning is in the name. Is there an element of market research, customer validation, or anything that you're currently working on learn and educate yourself more on?
Sorry, could you repeat the question?
Basically, what are you learning right now?
Okay, what am I learning right now? So what I learned right now is people with chronic illnesses like autoimmune conditions and other chronic illness, by definition, don't have any medicine or treatment that cures their disease. All they could do is figure out certain protocols, maybe like exercising or figuring out specific food items or specific habits that could help reduce the inflammation or make them feel moderately good. So these are all the groups of people that are very interested in preventative care because they literally feel physical or mental pain if they do not do preventative care. But other people who don't really have any issues yet are not motivated to do what it takes to get preventative care. For example, being logging habits diligently, taking blood work, getting blood tests done at least once a year, storing all this data and all the EHRs. It takes some work for you to take some preventative care. If there is no physical pain, people don't really do that because they're not incentivized to do that for a future risk. So I thought about this so much, like how do we incentivize people to take what it takes to get preventative care? There is no pain, but how about you reward people, right? People can be incentivized not just by lack of pain, but also by presence of a reward.
Mm-hmm.
So I realized that it's very important to be able to reward people when you deliver preventative care. Most of the healthcare apps, they try to solve a very niche health problem and in a very good way. But it's not fun to use any such healthcare apps. It is so fun to open Instagram and see reels, or open TikTok or open Facebook and see the posts because they have perfected direct to consumer experience. But you take any healthcare app on the market, it is so boring. It feels like, why am I even doing this kind of thing? So it's very important to be able to reward people so that the habit of staying healthy sticks with them. This is something that I recently learned.
All right, sweet. So I think we have time for one last question. What books? It doesn't have to be longevity related, but what books would you recommend people check out and read, and why, if you have a why?
What books? It's a very tough question. Probably, I would recommend people to read generally any physics books that tries to explain tries to explain at a macroscopic level, like what's happening and what the concept of time and all these things are. I was so it is so
I think I have one. I'm trying to find it. No, go. I think I have one by Stephen Hawking. I think it's called A Brief.
Yeah, that's nice. I have one here too. I would recommend to read this book though, for sure. It's called Now the Physics of Time by Richard Muller.
Yeah,
so
I think I found. No, it's all right. I'm sorry for interrupting. Keep going.
I like this book a lot, and generally any physics book too a lot, because it gives you a whole different perspective of time. There are two ways to solve longevity. One of them is to solve it biologically, and the other thing is to solve it using the laws of physics. There is whole other thing happening over there, where if you're traveling at speeds that are closer to the speed of light, then the time dilates and you are living longer. So if you're not interested in longevity, I would suggest to read something in physics, and you would still be interested in the concept of time.
Yeah. Well, I think technically you don't live longer. You live the same amount of years. It's the rest of the universe that is aging faster, right?
Yeah, again, it's a relative thing, how you say it.
Yeah, fair. All right. Well, then I want to thank you so much for coming on the show today, sharing what you're working on, and hopefully people can check it out. Is there a good way, any spot in particular that you point people at for checking out your work, or like staying up to date with what you're working on?
Yeah, so you could go to the website, which is Healome.one, or you could like follow Healome1 on its Twitter or LinkedIn profiles, which are also linked on the website. Or you could follow me on Twitter. It's my first name, last name, Nikhil Yadala.
Sweet. And all those will be in the show notes, but I just want to thank you for coming on the show today.
Thank you. Thank you, Lowell. Thanks for this wonderful discussion.